Hi there, this is Matt with ot3d.org. This video is part of a series of videos that I'm making designed to teach occupational therapy practitioners, educators, and students about applications for 3D printing in practice. My goal is to provide videos, resources, and instructional templates that will help walk you through the process of using a 3D printer. In this video, we're going to take a look at one of the CAD softwares that I like to use to introduce individuals that may not have a lot of drafting experience. It's called TinkerCad, so we'll jump right into it. If you can, I'd recommend that you go ahead and hop on your computer, pull up TinkerCad in a window, go ahead and create an account, and that way you can follow along with the guide as I walk you through the individual parts of TinkerCad to teach you how to use it. There are also other videos that I will be linking down in the description of this video that will go into a little bit more detail and have other projects that you might find useful as well. Alright, now that we've made an account, once we log in we'll be directed to this page right here. This is kind of a landing page. It'll host all of your designs that you've worked on that are on the account that you have, as well as some of the educational materials that TinkerCad offers. I highly recommend checking out these. Up at the top of the page here we have a gallery, some projects, the classroom especially, and the resources will also help guide you through using TinkerCad. While I hope this video serves as a great instructional guide, know that there are additional resources if you have more questions about it. I recommend this program to anybody that's starting out because it's such a good starter program. And if you want to transition to something a little bit beefier, something that has a little more tools, you can click on this little red tool up here that they have, and that'll actually take you to a link that teaches you how to use Fusion 360 after you have experience using TinkerCad, which I highly recommend. After this tutorial, we'll be creating a brand new design, so I'm going to come down here and click on Create New Design. That'll open up a brand new page, and with that, I will go ahead and change the name up here to something that is descriptive, with the hopes that I will be able to find it later. Alright, so up next, I'm just going to walk you through some of the basics. Up here on the right hand side you're going to see all of the shapes that you have access to. TinkerCad as a general concept works on the principle that you can take a shape, you can modify the shape. So let's take this cube right here, I'm going to throw him right in the middle of our build plate. And I want to go ahead and preface this by saying that the units that TinkerCad uses are by default millimeters. You can change these to inches with this little box over here. I personally recommend using millimeters. Get in the habit of it just because I find it to be a little bit more accurate to read if I'm using a caliper or something in real life to measure an actual thing if I'm trying to replicate it. So with that, now that I have my cube on the middle of the grid here, what I can do is I can come up to the top left hand corner and rotate. So when I click on this cube, I don't have a mouse on me right now, so using a laptop keypad, I'm able to click and drag to change my view. If you're using a mouse, you'll be able to use the left, right, and middle mouse buttons to kind of manipulate this. You can zoom in, zoom out, all the fun stuff. I personally don't find being in like a top view or any of those to be particularly helpful. I usually stay at an angle just for the sake of simplicity. So now that we have this cube down here, let's click on it and see everything that comes up. So there are a few settings that you can adjust over here in the pop-up box, but I personally find using the small boxes that actually pop up on the cube to be a little bit more useful. These black boxes that are down at the base, these allow you to increase or decrease the size in a single dimension. So if I wanted to change the length like this, then I can grab on that black box and that'll only change the length. But if I wanted to change multiple at the same time, what I could actually do is come over here and click on one of these white boxes in the bottom corners. And what I can do with that is I can click and drag, and that allows me to manipulate multiple axes at once. Now, let's say that I wanted to keep the size of the cube consistent throughout. What I can do is I can hold my Shift key on my keyboard, click on the white box, and drag, and that'll keep everything consistent, which is really nice for being able to scale objects. If I ever make a mistake and I want to go back, I have my back arrow key up here, or you can do Control-Z, as well as a forward arrow key if you need to move forward again. These you'll find yourself using quite a bit, especially in the learning process, and I highly recommend being familiar with those keys. You can also adjust the height of the cube by clicking on the small box up here, as well as the how high in the air it is by clicking on the small cone with any of these measurements, these small white boxes will pop up, and you can actually simply type a number into those and it will go to that number. You can also use the left, right, up, and down arrow keys to manipulate something with small increments. It's a little bit steadier than using a mouse, I find. Let's say I wanted to have a 30 by 30 cube. What I could do is type in the numbers 30 and 30, go up to the top button here that adjusts the height, and have that be 30 as well. Now, by clicking on an area of the cube that does not have one of those boxes, I can simply move it around the plane, which is very helpful if you're using multiple objects, which I'll actually take and put over here right now. If I wanted to rotate an object, what I can do is move to these little rounded arrows, and I can click and drag. If I'm further in, it'll default to click measurements, and if I take it further out, I can do finer measurements. I usually stick with the inner ones just because it's simple. Now I'm going to raise this back up to be flat on the build plate. One more way to manipulate objects is using the mirror function. So when I click on that, you can see that it brings up different options. So if I want to flip it this way instead, I can do that. With this, you won't be able to see it flipping, but it is. And if I wanted to bring it back down to where it was, I could again type in 90, drop it back down to the base. That number being 0 represents that. And let's see. So let's say, for example, I would like to build a little house shape with this. So I'm going to change the dimensions of this triangle right here to be 30 and 30, so it'll match the top of my square here. But the problem right now is that, well, my triangle is on the ground. So what I'm going to do first is I'm going to raise them up using this. Oh, went too far, so I'm going to type in 30 there. I can highlight both of these objects and use this tool right here, Align. That'll bring up a little grid system. So I'm going to hit the center button to center them up, center button to center them up, and there we go. I have a little house shape now. If I highlight both objects like this and come up here to the group function, I can then group them together. So long as they're touching, the areas that will touch will be welded together. Now, one thing that you might have seen as I've been adding shapes is the hole function. With any of the shapes in TinkerCAD, it can be a solid or it can be a hole. Let's say I wanted to have like a little birdhouse window. What I can do is I can drop down a little cylinder here. Let's make him, oh, I don't know, 5 by 30. Ooh, by 30. Make the height 5 to have a nice little dimensionally accurate cylinder. I can highlight both, align again, click, click, center them up, and group them. Once I group them, it'll actually put that hole in the object. Now let's say I made a mistake, I want to go back, I can go up here to ungroup, click on the object, let's say drop it down just a couple, and then group it again. And there we go. Now if I'm happy with this object that I've made, this little birdhouse shape, what I can do is come up here to the little export tab, click on export. If I have something clicked, it'll just be the selected shape, or if I want everything, if there's multiple shapes, I can do everything in the design. I will go ahead and export as an STL just to have future reference, and that'll download to my computer to where I can throw it in a slicer and 3D print it. Now while TinkerCAD has an export option, it also has an import option. So let's say I want to import that house that I just downloaded. What I can do is I can come up here to choose a file after clicking import. I can find that download file that I had, open it up. It'll show as scaled previously, but if let's say I wanted this to only be half the size, I could change that to 50%. That'll scale it down, and it will import as such. You can see that it is scaled down to literally 50% of the volume. If I wanted to scale it back up, I could click Shift, drag it back up until it's the correct size at 30. Ooh, a little too far, so I'll do 30. There we go. And we have two houses. One other cool function that I don't see a whole lot of people talk about for other CAD softwares is the ability to import SVGs. So an SVG is essentially a file that has a vector. With this, so you could take an image that's like a PNG or JPEG, use an editor like Photopea or Inkscape to convert it to an SVG. From there, what you can do is import that SVG. So what I'll actually do, I've been working on some flat splints for hand therapy. What I'll do is choose a file, go and find that SVG that I was working on. I can import that. Now this is going to import as very large. I don't actually need it to be that large, so we'll go down to like 25% here, and that'll get it closer to what I actually need it to be. I'll then click import, and it'll take a little while to load because it's not a standard format, and I don't need it to be this tall. That's a whole centimeter thick. I probably only need it to be like 2 millimeters high for flexibility, and after printing this, my goal is to be able to make a little thumb splint out of this. But that shows you how SVGs can be used. You'll want them to be filled in like this if you're doing something solid. If you just want an outline, you can just take an outline. It'll just depend on what you're hoping to use it for. But that just about covers everything that I know about TinkerCad, at least. I hope that you found this useful. There will be an associated visual guide that I'll be making with this if you want the steps at a slower pace to where you can just read off of it. I'll have that on ot3d.org, and happy printing!